So welcome to this PATRAN tutorial for basically loads and boundary conditions and symmetry conditions. Now, I'm doing this on special request of one of the students. I'm going to try and keep up and make all the other practical videos also for PATRAN. If I forget, if I'm slow, please don't hesitate to remind me. But of course, I'll try to bring it in for every example problem. Now, you are already familiar with what PATRAN looks like. I'm using it on remote desktop, so you see it in much shorter window, much smaller size, etc. But sorry about that. I don't have access to PATRAN on my Mac, and I haven't installed it on my partition, so I'm using it on remote desktop. So once you have started your model, of course, and you have a lot of conditions that are acting on the kind of model that you have. But in general, in PATRAN, it's much less rigid as to what kind of loads and boundary conditions you can apply. Of course, if you apply the wrong load to a different kind of model, for which it is not appropriate, it will give you a warning and an error and probably subsequently not work out at all. Now, where to find these loads and boundary conditions in your PATRAN database system? So if you look here, you have this whole very clearly defined section called loads, boundary conditions. The distinct difference here between PATRAN and Abacus is that there are no inbuilt functions for symmetry conditions. That means you would have to apply displacement boundary conditions judiciously so that you have symmetry conditions, which can of course be derived by using force and moment equilibriums for what you apply for, and you see whether actually the free body diagrams add up and you have equilibrium in the entire system. So if you open loads boundary conditions, you see different kinds of loads can be applied. You have displacements, forces, temperatures, velocities, acceleration, even up to the point of having an initiation for a crack. You can also see here that it says nodal loads. That means these are loads that are only applied at nodes, and these are loads that are applied on the element. So you see there are certain distinct differences. Displacements can be applied at nodes and at elements, but the others not necessarily. Temperature as well, but if you have a concentrated force, then you can only apply it at node. But if you want to apply it on an element, you will have to have a distributed load or a CID distributed load, and CID here stands for the coordinate system in which you are applying the load. You can also apply inertial loads to an element. You can apply pressure loads to an element because this is also applied only to a surface area, and of course nodes are points, so they don't have surface area. You can also apply total load to the system as to what would be the complete load, and then PATRAN will calculate, or Nastran actually will calculate what should be the load distribution over the entire body. And there are also other parts that are slightly hidden here, so you can pull it out and see what they are, but otherwise you can also go in here to see. If you see create, you can drop this down to see many different options as to what you can do for applying loads and boundary conditions. So these are all mostly boundary conditions and loads put together. If you want to apply initial conditions, you can also apply them here. So if you have a velocity in an impact condition, or if you have an acceleration on your body, then you can apply those as initial conditions as well. If you have residual stresses, for example, of parts that are coming out of an oven or something, and then you want to load it, you can also apply residual stresses as initial conditions. Now, one important thing to note here in PATRAN is that when you create a displacement, say suppose we want to create a nodal displacement, then you first need to enter a name. So let's say I call it dummy, and I click on input data, and I enter some data over here in translation rotation. I must very clearly do OK, select application region, apply it to an application region, and at the end of it hit apply. If I don't hit apply, it doesn't get created. It's very simple. Now, if there are other options here like spatial fields, etc., which will come in later. When you, for example, want to apply a distributed load, then you can define a field before, which is like a function, and says that over a distance x, I want to apply load wx, which changes in the way that w into 1 plus x squared plus x cubed is equal to something, right? You want to define the spatial field, and then you can write that here. So if you apply a load which has to depend on that spatial field, you can basically write 1 or the scale factor here, and then click on the spatial field to make it attached to that translation. So there are different things that you can do. There are a lot of freedom. Now, when you create boundary conditions and loads in PATRAN, you can first also create a load case. So you can give it a name like a dummy or something, and then you can pick what kind of load case it is. So if I say I want to create a load case, I give it a load case name here, dummy, and I make it the current load case, and it's a static type problem. And under input data, if whatever displacements and boundary conditions I have or loads I have are here, and if I just keep clicking on them, then it gets added to my current condition. And then once they have all been added to my load case, I can do OK. And if it is current, then whatever load and displacements I create actually gets saved directly into that particular load case. You can also choose particular load cases to run the analysis. So if you go into analysis, you can also choose like which particular one you want to use. So if I want to analyze, you want to do analysis. Yeah, sorry about this, it's a bit slow because of being used in the remote desktop version. So if I have analyze entire model full run, I can also do analyze entire model, and then under subcases I can select which load case, and here you will see a list of load cases that you can actually pick up to run the analysis. It's very important to note that loads can be applied either on, or displacements as well, can be applied either on nodes or on geometry. So either you apply it on the mesh or you apply it on the geometry. Now in principle, the mesh is attached to the geometry. And if you want to change the mesh, then it's better that your load or your boundary condition is always attached to your geometry. Because if you change the mesh, then your load and boundary condition has to be applied to the mesh all over again. So try to make certain that you have your mesh associated to your geometry and your loads and boundary conditions associated to your geometry. And only then in that case, the loads will also be associated to your mesh by default. In PATRAN, this sometimes leads to problems, but not always. So you'll have to try a few times and see which is the best method for you to attach loads to the geometry and mesh also to the geometry. This is all I have from about loads and boundary conditions. We didn't do any example this time, but that's also because you are doing a peer-to-peer evaluation. We will see you again this week on Thursday to follow some other tutorials.